Far below the surface of the ocean, there is a world without sunlight. A world where darkness is absolute. No sunrise. No sunset. Just endless black water stretching for miles in every direction. At these depths, the pressure is crushing. The temperature hovers just above freezing. And food is incredibly scarce. To us, it would seem like one of the most hostile environments on Earth. And yet, life thrives here. But not the kind of life you might expect. Because in this deep, silent darkness, many creatures glow. Fish flash electric blue lights from their bodies. Jellyfish pulse with ghostly green halos. Tiny drifting organisms sparkle like underwater stars. Entire sections of the deep ocean can suddenly light up, as if someone flipped on a cosmic switch. Which raises a strange and fascinating question. If the deep sea is completely dark, why are so many animals glowing? Why would creatures living in total darkness produce their own light? It seems almost pointless. Or even dangerous. After all, in a place filled with predators, glowing could make you easier to find. But this is where things get strange. Because the glowing lights of the deep sea are not accidents. They are part of one of the most sophisticated survival systems ever evolved in nature. A system scientists call bioluminescence. And in the deep ocean, it's everywhere. In fact, researchers estimate that more than 3/4 of all deep-sea animals can produce light. That means most of the creatures living thousands of meters below the surface are glowing in some way. But the real mystery isn't just how they glow. It's why. To understand that, we have to go deeper. Much deeper. The ocean is divided into layers. Near the surface lies the sunlight zone. This is where most marine life lives. Sunlight penetrates the water. Plants grow. Coral reefs flourish. Fish swim through warm currents. But once you descend below about 200 meters, sunlight begins to fade. Colors disappear. Red vanishes first. Then orange. Then yellow. By the time you reach around 1,000 meters, the ocean becomes almost completely black. Scientists call this region the midnight zone. And this is where bioluminescence truly dominates. Imagine standing in a forest at night with no moon, no stars, and no flashlight. Now imagine millions of tiny creatures suddenly flickering on and off around you like floating fireflies. That is what the deep ocean often looks like. But unlike fireflies, these animals aren't just glowing for decoration. Their light is a tool. A weapon. A disguise. And sometimes, even a language. The secret behind this glowing ability lies in chemistry. Inside the bodies of many deep-sea animals are special molecules. Two of the most important are called luciferin and luciferase. When these chemicals mix with oxygen, they trigger a reaction that produces light. No heat. No flame. Just pure glowing energy. Scientists call this type of light cold light, because almost none of the energy is wasted as heat. In fact, bioluminescent reactions are incredibly efficient. More than 90% of the energy becomes visible light. For comparison, a normal light bulb wastes most of its energy as heat. Nature, once again, has engineered something far better than our technology. But even more fascinating, different species glow in different colors. Some shine blue. Others glow green. A few rare species even produce red light. But this is not random. In the deep ocean, blue light travels the farthest through water. So many animals evolved to glow blue, because it can be seen across greater distances. It's the underwater equivalent of using a brighter flashlight in the dark. But the real reason deep-sea creatures glow has less to do with visibility, and more to do with survival. Because in the deep ocean, there is a very simple rule. Everything eats, or gets eaten. And bioluminescence has become one of the most powerful survival tools ever invented by evolution. Take the anglerfish, for example. One of the most famous creatures of the deep. Its appearance is almost nightmarish. Huge teeth. A massive mouth. And dangling from its head, a glowing lure. This lure is actually a modified spine filled with bioluminescent bacteria. The anglerfish waves it slowly in front of its mouth. Like a fisherman dangling bait on a hook. Small fish in the darkness see the faint glowing light, and swim closer to investigate. But by the time they realize something is wrong, it's already too late. The anglerfish opens its enormous mouth and swallows the prey whole. And that glowing lure? It's essentially the deep-sea version of a neon, free food sign. But predators aren't the only ones using light. Some animals use bioluminescence to hide. Which sounds completely backwards. How could glowing possibly make you less visible? But the answer lies in something called counterillumination. To understand it, imagine you are a fish swimming in the middle depths of the ocean. Below you is darkness. But above you, faint sunlight still filters down from the surface. Predators lurking below can look upward and easily see the silhouette of anything swimming above them. Your body blocks the light, creating a dark shadow, which basically turns you into a floating target. Unless you can erase that shadow. Some species of squid and fish have evolved glowing organs on the underside of their bodies. These lights shine downward, matching the brightness of the faint sunlight above. From below, the animal's silhouette disappears. It blends perfectly into the background light. It's essentially invisibility through illumination. Nature's version of stealth camouflage. But this is only the beginning. Because some deep-sea creatures use light in ways that are far more bizarre. Some flash bright bursts to blind predators. Others release glowing clouds into the water, like an underwater smoke bomb. A few species even communicate using complex patterns of light pulses. And that's not even the weirdest part. Because one deep-sea creature has evolved a glowing weapon so strange, it almost sounds like science fiction. A fish that uses red bioluminescent headlights. In a world where almost no animals can see red light. Which means it can illuminate prey, without being detected. To understand how that works, we have to meet one of the ocean's most unusual hunters. But that story goes even deeper. In the deep ocean, vision is everything. Because when the world around you is completely dark, the ability to see even the faintest light can mean the difference between life and death. Most deep-sea animals have evolved extremely sensitive eyes. They are tuned specifically to detect blue light. And for a very good reason. Blue wavelengths travel farther through seawater than any other color. It is the only color that survives long journeys through the dark ocean. Which means most bioluminescent creatures glow blue. And most animals have evolved to see blue. But this is where things take a very strange turn. Because one group of deep-sea predators has discovered a loophole in this system. A biological trick that gives them a private flashlight, invisible to nearly everything else. Meet the dragonfish. At first glance, the dragonfish looks like something pulled from a nightmare. Its body is long and slender. Its skin is dark as coal. And its mouth is filled with needle-like teeth that look far too large for its head. But the dragonfish's most unusual feature isn't its teeth. It's its light. While most deep-sea creatures glow blue or green, certain dragonfish species can produce red bioluminescent light. And that might not sound impressive at first. But in the deep sea, it's extraordinary. Because almost no animals down there can see red. Red light disappears quickly in water. Even sunlight loses its red wavelengths within the first few meters of depth. By the time you reach the deep ocean, red light simply doesn't exist. Which means most animals never evolved the ability to detect it. To them, red light is essentially invisible. But dragonfish have evolved special pigments in their eyes that allow them to see red wavelengths. So when the dragonfish activates its red glowing organs, something incredible happens. The ocean in front of it lights up. But only for it. Imagine walking through a dark forest at night with a flashlight that no other animal can see. You can spot your prey clearly. But they remain completely unaware. That is exactly what the dragonfish does. It scans the darkness with its private beam of red light, searching for unsuspecting prey drifting through the black water. And when it finds one, the hunt begins. But the dragonfish is only one example of how strange bioluminescence can become. Because in the deep ocean, light isn't just used for hunting. It can also be used for defense. Take the vampire squid, for example. Despite its terrifying name, the vampire squid is actually a relatively small and delicate creature. It drifts slowly through the oxygen-poor waters of the deep sea, feeding mostly on falling debris known as marine snow. But when threatened by a predator, the vampire squid does something extraordinary. Instead of releasing ink like a normal squid, it releases a cloud of glowing mucus. Thousands of tiny luminous particles burst into the water. The predator suddenly finds itself surrounded by flashing sparks of blue light, swirling like underwater fireworks. This glowing cloud confuses and distracts the attacker long enough for the squid to escape into the darkness. It's the deep ocean equivalent of throwing a flash grenade. And that's not even the weirdest part. Because some of the smallest creatures in the ocean have turned bioluminescence into something even more spectacular. Out in the open sea live trillions of microscopic organisms called dinoflagellates. Individually, they are almost invisible. But when disturbed, each one emits a brief flash of blue light. When waves crash against a beach filled with dinoflagellates, the water suddenly glows electric blue. Ships moving through these waters leave trails of glowing wakes behind them. Even fish swimming beneath the surface can create shimmering rivers of light. It looks like the ocean itself has turned into liquid starlight. But this glowing reaction isn't just beautiful. It's defensive. When a predator disturbs the dinoflagellates, their sudden flashes of light can attract larger predators. In other words, the tiny plankton are essentially screaming, "Help," in the language of light. The attacker suddenly risks becoming prey itself. It's an alarm system written in biochemistry. But perhaps the most fascinating thing about bioluminescence is how ancient it is. Scientists believe glowing organisms may have existed for hundreds of millions of years. Long before dinosaurs walked on land. Even before many modern animals evolved. Bioluminescence likely first appeared in microscopic marine organisms, possibly as a way to neutralize toxic oxygen molecules. But over time, evolution began experimenting with this glowing chemistry. Some species used it for camouflage. Others used it for hunting. Some even evolved complex light patterns to attract mates. In certain species of deep-sea squid, males and females recognize each other using precise flashing signals. Like a secret code written in pulses of light. Which means the deep ocean may be filled with silent conversations happening entirely through glowing signals. A language we are only beginning to understand. And yet, despite decades of research, the deep ocean remains one of the least explored places on Earth. More than 80% of the ocean is still unmapped. Entire ecosystems may exist down there that we've never seen. Creatures glowing in colors we haven't yet discovered. Using light in ways we cannot yet imagine. Because evolution in darkness follows very different rules. When sunlight disappears, organisms must invent their own solutions. And bioluminescence may be one of the most brilliant solutions nature has ever created. In the darkest parts of our planet, life didn't simply adapt to the darkness. It learned to create its own light. Tiny sparks in a vast black ocean. Signals of survival, written in glowing chemistry. And perhaps that is the most fascinating truth of all. The deeper we explore the ocean, the more we realize that darkness does not mean emptiness. Sometimes, it simply means we haven't learned how to see the light yet.